of what the app does functionally, these 9 requirements need to be met anyway. So first and foremost is security, and generally very closely related to security is compliance. It is critical to ensure that appropriate policies are aligned with industry best practices and they are enforced at all layers in the stack. You have to ensure that you're thinking about confidentiality and the integrity of the data your app uses. And then in order to ensure that the app is compliant with any of the various compliance standards and guidelines, those policies must be included and enforced as well. Next up, availability. Most customers expect your app to be available 24/7, 365. No downtime, not even planned downtime ideally. Let's talk about scalability. Your app needs to scale from tens to thousands to millions of users and handle increasing volumes of data without needing to redesign the app. Performance. Your goal is to provide the lowest possible latency and highest possible throughput or the best possible user experience you can give your customers. Agility. If you think about it, agility is perhaps the most important driver of the modern app paradigm. You have to keep up with customer expectation of how quickly they can get the latest feature. So you can't really be bottlenecked by manual processes in the build and the development cycle of your app. Observability. You should be able to monitor all aspects of your application: uptime, latency, performance, etc. Your app developers should have alarms set up that go off when thresholds are breached on any of these KPIs. Let's talk about resiliency. Regardless of everything you do, there are bound to be situations that risk your app's availability or your app's performance, or even worse, the durability of your app data. So it's critical that you build in resiliency from the get-go. You have to ensure that the app can recover gracefully, and you have to make sure that you're designing to prevent data loss. Cost optimization. There's a lot of requirements here, and you're making a lot of choices to support those requirements. You have to be intimately aware of the costs involved here and optimize to drive that down. And finally, portability. Ideally, your application should be portable across various runtime environments. So what that typically implies is that you leverage open standards or open source because that tends to have a high degree of familiarity to developers. You really don't want to make design or technology choices that limit how easy it is to ramp up new developers coming onto the app. Okay, now that we understand the requirements, how do we go about fulfilling these? It turns out that the problem here is there's almost too broad a set of choices and decisions that developers and architects have to go through as they think about how can they meet these requirements. And of course, you would rather they spend this time in developing the actual app's functionality. So we can simplify the decision making around these requirements. The developers and the app architects can get that time back. At Oracle, we've thought very deeply about these challenges, and we've arrived at a set of 10 design principles that guide both how we think about our own applications and the services that we build that our customers build their apps with. So our goal with these design principles is to benefit developers to focus on coding the app. And just by using the technology recommendations associated with these design principles, meet the core requirements that we identified earlier. So here are our 10 design principles to develop modern apps. These principles cover the entirety of the application lifecycle: how you develop, build, package, deploy, secure, and operate your apps. So in the next few minutes, we'll talk a little bit about each of these. Why are they important? How they help? And specific technology recommendations aligned with each principle. So let's get started. So our first principle focuses on how you develop your apps. Use lightweight frameworks and mature programming languages. So the programming language, the library, and choices that you make around a framework, the patterns you adopt to build your app, these are very critical in defining the maintenance costs of your application over time. The languages, the framework choices have long-term impact on how are you scaling your business, how are you operating your applications, and how are you delivering those high-quality features to your customers. If you make changes in these choices, you're incurring a high switching cost. So, in terms of language, mature languages with mature ecosystems are going to prove far more dependable than newer ones that tend to have a high change rate, both in the design and in the ecosystem of the libraries that are involved. The application framework you pick should ideally be able to provide sensible, non controversial defaults for common things like logging, telemetry, security, configuration. It should also provide you common patterns. An example of this would be building a REST API that should just be built into the framework. So, our recommendations are that you should use Java as your language choice. Java is obviously an incredibly mature language, very stable, and it's a very broad set of capabilities that covers a wide swath of app use cases. It also has a very healthy ecosystem of libraries and frameworks. For the JDK, use Graal VM to develop and run your apps. So this allows you to combine Java stability with best-in-class performance. You're also getting the benefits of the proactive patching for a better security posture and built-in diagnosis tooling. In terms of frameworks, we recommend you use either Helidon or Micronaut. So if your app is aligned to the enterprise Java ecosystem, then Helidon's standards first support for modern Java enterprise patterns through microprofile makes it easy to modernize your existing JEE apps. If you don't have a dependency on the enterprise Java ecosystem, Micronaut is interesting. Micronaut provides you compile time scaffolding, so you get increased performance. More interestingly, you get framework level checking, so you can avoid security and quality issues around reflection and runtime configuration. Let's move on to our second principle. Build your apps as services that communicate over APIs. Rather than a monolithic approach, building an app as a set of independently scalable services that encapsulate specific functionality allows you to make your development team far more agile. So the API contracts between these services provide the mechanism to collaborate on the functionality without depending on the internal details of the implementation of each of these services. So for example, a service can be wholly owned by one development team and they can freely improve on the implementation without having to coordinate code dependencies with other teams. So begin with a contract first approach that is based on the business requirement. Describe the behavior of the service, and you can do this using a format that's agnostic to the implementation, like OpenAPI. Then you can prototype that API, let the consumer of the API try it, and then the implementer can make that work. So you've essentially built an iterative way to arrive at consensus. So both the producer of the API and the consumer of the API can be different teams that are working independently of each other. Now, in terms of the technology recommendations here, we already talked about OpenAPI standard. Now, the tooling that goes with that is Swagger tooling. This allows you to generate OpenAPI specification-based descriptions. So you can then use infrastructure as code techniques to manage the deployment of these and version control those API descriptions, along with the backing code that implements those APIs. You should also define policies that need to be enforced for these API interactions. For example, what type of validation do you need to do on these incoming requests? Is there any rate limiting that is a requirement? Do the responses need to be cached? You do these through an API gateway. So the Oracle API gateway is basically a common point of enforcement, and it shields the consumers from back-end implementations. So our third principle is about how you package your applications. Package and ship your apps as containers. Now, containers package your app code and dependencies as one unit, so you can run these reliably across multiple heterogeneous environments. And this makes them extremely portable. So regardless of whether you're running on premise, or you're running a physical server in the cloud, or you're running a virtual machine, you get the same result every time. So you now have a simplified and consistent approach across development, management, observability, and governance for your app. And because containers run across multiple environments, you're effectively avoiding vendor lock-in in the design of your app. Now, we talked in principle 2 about breaking down the app into services that perform discrete operations. This principle is telling you to package those services as containers. If you have existing apps, gradually replace existing functionality with the containerized versions until you can replace the entire app. So the key technology recommendations that are related to this principle are the Oci Container Registry, commonly known as OCIR, and this allows you to store and share container images, and the Oracle Container Engine for Kubernetes, or commonly known as OKE. And this enables you to provide a fully managed Kubernetes-based container orchestration, which allows you to run these and manage these containerized applications at scale. Additionally, we also natively integrate these services with platform capabilities like logging and observability. Obviously, security is critical as well. So a closely related technology recommendation here is the OCI Vulnerability Scanning Service, because this service enables you to improve the security of the container environment by scanning images in OCIR for vulnerabilities. You can then use the results from these scans to determine whether these containers can be deployed at all to OKE. Okay, let's move to principle 4, automate build, test, and deployment. Now, continuous integration and continuous deployment, more commonly known as CI/CD, are a set of tools, practices, and processes that teams use to deliver code changes frequently and reliably. Right? And this spans all areas in the lifecycle: code reviews, unit testing, integration testing, check-in processes, filing tickets, deployments to various types of environments, staging, pre-production, production, etc. It also applies not just to application code, it applies to also deploying infrastructure that's underpinning that application. So standardizing the development lifecycle through CI/CD allows you to build in reliability and security in a much more consistent way. So in terms of the technology recommendations here, these are the OCI Artifact Registry, Oci Devops, and the Resource Manager service. Artifact Registry provides a version control repository that allows you to store and share various types of artifacts that your application is comprised of. So think libraries or zip files or software packages, etc. Oci Devops is a newly launched continuous deployment service, and this lets you deploy these artifacts that represent your workloads at scale. So you can do really interesting things with this. You can track the history of your deployments. You can set up gates to define the required conditions for deployments. You can roll back deployments if you're failing validations, etc. And finally, the Resource Manager service. This is a fully managed Terraform-based service that automates your infrastructure creation at scale. You just write your Terraform scripts, and the service lets you run those to create your infrastructure. Principle 5 tells you to use fully managed services to eliminate complexity across application development, runtimes, and data management. By using fully managed services that take care of managing infrastructure maintenance, automated scaling, and patching, the app developer can focus on creating customer value. And the developer gets best-in-class solutions without needing expertise in each of these areas.